Now let's solve a couple of problems. In the first problem, researcher reports that the average salary of assistant professors is more than 42,000. A sample of 30 assistant professors has a mean salary of 43,260 at alpha is equal to 0.05. Test the claim that assistant professors earn more than 42,000 per year. The standard deviation of population is 5,230. Okay, we have what we want to test. The claim that assistant professors earn more than 42,000 per year. So this is going to be our H1. So that's what we want like to claim. So this is our claim. Again, opposing like to something what we knew before. Okay. So this is going to be our H1, and this is going to be our claim. Okay. So this is our claim. So then our 0 is going to be mathematically opposite to H1. It's less or equal than 42,000. Okay. Again, we can state that it is equal to 42,000 as shown like in the book for the procedure of hypothesis testing. Totally fine with me. Okay. So then also what we need to right away understand while we are reading the problem what distribution we are going to use and what tail test it is. So since it's more than, that means it's the right tail. Okay, so this is the right tail. And the standard deviation population is known, so it can be known from the previous study, and is equal to 5,230. Okay. So we are going to use the standard normal distribution, and this is the right tail test. Okay, alpha in this case is 0.05. So that's what it is. Alpha is area under the curve, which is being cut by the critical value. So critical value, and we need to calculate that critical value. I've already put it here. It is 1.645 up to the third digit. But what you need to do, you need to calculate it using Excel, and we use the standard. We use normal standard distribution inverted, and we cut 0.05 on the right. That means we are cutting 95% of the area on the left. 0.95. That's what we cut on the left. Again, remember all those functions, they are calculating the area from the left of the value. Yeah, so in this case we are taking 0.95 and we find such a z value which is cutting like the 95% area from the left. So that's how this function works. Okay, as you can see, I've already formatted this cell up to the third digit, and as you can see, it's exactly the same as shown here. Okay, so now we calculate the test statistic, and this is the mean of the sample, which is 43,260 minus the mean of the population, which is 42,000, and divided by the standard deviation, which is 5,230, divided by square root, divided by, don't need brackets here, square root of 30. Okay, and that's what we have. So it's 1.32. 1.32, our test statistic. Our test statistic is somewhere here. It's less than 1.645. And what does it mean? That means that we do not reject H0, so we are out of the critical region. So that's what we are going to do here. So let's maybe insert the text box, and let's maybe put the background, and we will write that we are out of critical region. That is why we do we do not reject H0. So we can't reject H0. Yeah. So which is 42,000. So it's less or equal than 42,000 or equal to 42,000. So that's a conservative kind of configuration. This is not it. Yeah. So we are checking the claim that assistant professors earn more than 42,000 per year. So see, we are rejecting H0. What does it mean? We are not rejecting H0. That means we do not have enough evidence like to claim that. Yeah. So since we are not rejecting H0, we do not have enough evidence to claim that. So we write the conclusion. So we go and insert another box, and we write the conclusion. Yeah, we write the conclusion, and conclusion is as follows. We do not have enough evidence to claim that professors earn more than $42,000 per year. Okay. So that's your final conclusion. Okay. So this is your final conclusion right there. So this is just some intermediate result, and this is the final conclusion. Yeah. So we were asked to test the claim that assistant professors earn more than 42,000 per year. So our conclusion that we do not have enough evidence at this significance level of 0.05 to claim that professors earn more than 42,000 per year based on this data. Okay. So 5 steps. So 5 steps of success. 5 steps. Where's my camera? Here. 5 steps of success. Okay. Okay, let's save this and let's go and solve another problem. Okay, in this problem, a medical investigation claims that the average number of infections per week at hospital in southwestern Pennsylvania is 16.3. A random sample of 10 weeks had a mean number of 17.7 infections. The sample standard deviation is 1.8. Is there enough evidence to reject investigators' claim at alpha is equal to 0.05? Okay, so we have a medical investigation claims that the average number of infections per week at a hospital is 16.3. Okay, so that's what we claim. Nefarious to reject investigators' claim. Yeah, to reject investigators' claim. So in this case, we put this as a claim. Yeah, so this is a claim. So this is our H0. Yeah, so our H0, and investigator claims that it's exactly 16.3. So this is the two-tail test. Okay, and the sample standard deviation is 1.8. So if the sample standard deviation is 1.8, so then we are going to use t-distribution. This is two-tail test and t-distribution, since we do not know the standard deviation of population. Okay. Okay, so sample. Let's see. So it's now per week at the hospital. The sample is there is enough evidence to reject investigators' claim? Yeah, so to reject in investigators' claim. So again, as you can see, we are opposing. Yeah, we are opposing like that some like prior knowledge that it is 16.3. Okay. Okay, so we are trying like that. This claim is wrong. Yeah, so this claim is wrong. So that's what we are trying like to do. Okay, so alpha in this case is equal to 0.05 alpha over 2. Yeah, this is equal to this divided by 2, so it's 0.025. So we split our significance like into two tails. Okay, so that is why we take significance and divide it by 2. Okay, so the degrees of freedom in this case, it's degrees of freedom equal to n minus 1. So those are degrees of freedom which we need to state for the t distribution, and in this case that's sample size is 10. Yeah, we can write that it is equal to 10 minus 1, and this is equal to 9. Okay, this is equal to 9 in this case. Okay, the critical values, we have two critical values. So one is cutting the left tail, another one is cutting the right tail. Okay, we have equal to t distribution inverted. Again, we have a couple of options here for the t distribution. We can put t inverted, and we can put let's say 0.025. So this is going to be our negative value, and then here we need to state degrees of freedom, 9 in this case, and you see that's a negative value. Positive value, we can let's say take this and just take it with the minus sign. This is going to be our positive value, which cuts the right tail. Also, we can do it with the two-tail function, for example, as an option. Yeah, as an option, we can also do it as t distribution inverted two-tail, and instead of, so again, quite common mistake is to put here 0.025. So some people are using like that two-tail function, but for some reason they're taking alpha over 2. So again, like the whole idea of that two-tail function is actually like to take 0.05, your significance level, and do like that proper procedure for two-tail test, taking that significance, dividing it by 2, and then calculated the inverted function. So that is why in this case it is this, yeah, and it is this, and it is 9. Okay, the degrees of freedom, and we should get this value positive. Yeah, so we should get this value positive. Okay, so this is the absolute value. So this is the absolute value of our critical value. Yeah, of our critical values. Yeah, so they are symmetric, and their magnitude is the same. Yeah, so the absolute value of those two numbers is the same. Okay, you can do it like this. Okay, so that's what we have. Those are our two critical values. So one is cutting the left tail, another one is cutting the right tail, and then we calculate the test statistic, and it is equal to the sample. The mean sample is 17.7. So it's actually like the same as the z value, but instead of the standard deviation of population, here we are taking the standard deviation of the sample, minus 16.3, and we divide everything by standard deviation of the sample, which is 1.8, divided by the squared root of 10. So that's the sample size. Okay, so it's 2.46 reasonable, and 2.46 it is located right there. Yeah, so it is located right there. So it is within the critical region. So it is within the critical region. And since we are in the critical region, we reject H0. Yeah, so we reject H0. So let's put this intermediate conclusion. So let's go ahead and insert the text box here. Okay, so we are in the critical region. That is why we reject H0. Okay, so now we write the let's maybe copy paste that stuff. Okay, so since we rejected H0, we need to answer this question now. Is there enough evidence to reject the investigator's claim? Yes, there is enough evidence to reject investigators claim that the average number of infections per week is 16.3. Yeah, we can put hospital is 16.3. Okay, that's it. Yeah, so we are again we are in the critical region. That is why we reject H0, and the question is there enough evidence to reject the investigator's claim? Yes, there is enough evidence to reject investigators reject investigators' claim that the average number of infections per week in hospital is 16.3. Okay, so as you can see, I am answering always like the question from like the problem. I'm not just saying I reject H0. Yeah? I'm not just saying this. Yeah? I am answering like the question which is stated in the problem. Okay, so hope this helps, and in the next video I'm going to go through the confidence intervals, and I will introduce the other approach to test the claim, which is called the p-value method.